Okay, so what we looked at in the last video was looking at naming ionic compounds. This is still looking at that, but we're going to look at some different things. Last video we looked at monatomic versus polyatomic and how the ending changes whether you've got "-ide" or "-ate". This video we're going to look at transition metals and the exceptions. So transition metals, remember, are groups 3 through 12 on your periodic table. And these are unique when we're trying to name them because, as we've been looking at with the periodic table, I keep kind of telling you that transition metals can lose different amounts of electrons, of valence electrons to be specific. So we don't really know what their charge is going to be. We couldn't specifically say it's going to be 1 plus, it's going to be 2 plus. But I can tell you this, they are positive because they're metals and they will lose electrons. But in our name, what we're going to have to do is we're going to have to figure out what the charge is. By looking at the compound, we're going to have to figure out the charge and state that as a Roman numeral when we're naming. So you guys did these last year. It would be something like copper 2 nitrate. So you're going to have that Roman numeral. That Roman numeral 2 means that copper was carrying a 2 plus charge in the compound when it was crisscrossed. But we don't know that. That's why we have to put that in the name. So we're going to work on practicing with these. So my first example is is Fe2O3. Sorry about that. Fe2O3. So you guys already know how to name this. Pretty much, you're just missing the Roman numeral. You know that Fe is, I'm going to write it. Let's see, I'm going to write it down here at the bottom. Fe is iron. Oxygen, O is oxygen, and it becomes oxide. But the problem is iron is a transition metal. It falls in groups 3 through 12 on the periodic table. So anytime you're naming those elements, you're going to have a Roman numeral telling me what the charge is. So the only way that you can figure this out is you got two ways. 80% of the time, the easy way will work. You can look at this and you can say, okay, I've got Fe2O3. Well, these were crisscrossed to get those numbers down at the bottom. So this 3 would have been the charge on iron. So that tells me it's going to be 3 plus. If it's something that hasn't been reduced, that's going to work for you. But if it's something that's been reduced, you're going to have to go with a method that a lot of physical science people had trouble with, but hopefully maybe you can catch on to this. So if I look at this, I've got Fe2O3. I don't know what the charge is on iron, but I can look up and figure out what oxygen is. It's in group 16, means it has 6 valence, so it's going to gain 2. And you should have this written on there. It's 2 minus. Well, if it has a 2 minus charge, and there's 3 of them, that is a total negative charge of 6 minus. Well, for these two to be in a compound and be an actual compound, the charge has to be 0. That means the positives have to equal the negatives for that to work. That tells me on this side, I need this to be 6 plus because those two right there are going to balance to that 0 charge. So I've got to figure out if I've got 2 atoms of iron, what do I multiply those 2 atoms to get 6? Well, 2 times what is 6? That would be 3. So that means that iron was carrying a 3 plus charge. That right there is your Roman numeral, not the 6's down at the bottom in black. It's the charge on the iron atoms. So then in your name, you would put iron, and you would give me a Roman numeral 3, oxide. If you don't know Roman numerals, this would be 1, this is 2, this is 3. 4 is the harder one that people kind of get hung up on. It is IV. And then 5 is just a V. And then when you move to 6, it's VI. 7 is VII. And then if you get to an 8, which I don't think you would, it would be VIII. I don't think you're going to have any Roman numerals higher than that. But you might want to jot those down if you don't know how to write your Roman numerals. So let's try another example. We've got AgNO3. So basically I've got a cation and I've got an anion that I'm dealing with, which is the Ag and the NO3. That's kind of, I don't like that. So the Ag is my cation and then the NO3 is my anion. So if I look up Ag on the periodic table, it's silver. So I'm going to write that down here. NO3 is polyatomic. There's more than one element there, so I've got to look that up on the chart. So NO3, if you look that up, it is nitrate. Now, because silver is in groups 3 through 12, I've got to figure out what the Roman numeral is. So basically, if you look at this, there are not 3 nitrates. There's one nitrate. That one nitrate has a nitrogen and it has 3 oxygens, but there's still one of them out here. And there's also one silver. So if I've got 1 and 1, if I can just figure out what the charge of nitrate is, I've got the charge of silver. You can look that up on your chart. It's 1 minus. Well, to balance and be neutral and be to 0, that means that silver is 1 plus. So this was a pretty easy one. So this Roman numeral is just going to be a 1. So you've got silver 1 nitrate. Next example, I have CuCl2. So Cu on the periodic table is copper. And Cl on the periodic table is chlorine, which means it's monatomic, so it will become chloride. So now I've got to figure out, and I'm going to write it kind of bigger so I can do the math. Again, you don't know what the charge is on the Cu, but you do know what chlorine is. If you look it up on the periodic table, it's 1 minus. Well, there's 2 atoms. So those 2 atoms you would multiply. That would make this bottom charge 2 minus. So that means over here, to balance these 2 to 0, I need this to be 2 plus. Well, there's only 1 atom here. Really, it's not written, but it is assumed that there is 1 atom there. So you say, what do you multiply 1 by to get the 2? Well, it would have to be 2. So that tells you that the charge on copper is 2 plus. And that's your Roman numeral in the name. That right there would become your Roman numeral. So that is how you actually get the name of it. You can work the other direction and just practice writing the formula of them for transition metals. Now these are going to be a little bit easier than the ones we were dealing with, because as soon as you come across that Roman numeral, that tells you the charge on that element. So nickel 2 means nickel has a 2 plus charge. And then you could look up nitrate. On the chart, it's NO3. It has a 1 minus charge. So you just crisscross, same as we were doing in the last video. It would be Ni1 from that 1 right there, and then NO3 2. So because there's 2 of them, we've got to put that in parentheses and have a 2 outside of there. So iron 2 hydroxide, do this in a different color. Fe2 means iron is carrying a 2 plus charge in that compound. Hydroxide, if you look that up, is 1 minus. So this is going to be Fe1OH2. And then the last one, silver 1 sulfate. Silver 1 means silver is carrying a 1 plus charge. Sulfate, if you look this up on the periodic table, or I'm sorry, on your chart, it's 2 minus. So this would be Ag2 SO41. And that is how you do that. There is one last thing that we have to cover. It is exceptions to the transition metals. So I did say all elements from groups 3 through 12 need a Roman numeral, but there are also a couple of elements that need that. There are also a couple of other elements that are going to need Roman numerals. They are lead and tin. Lead is Pb and tin is Sn. So anytime you run across these elements, they will also need a Roman numeral in the name. So I gave you an example here. You've got PbO. So you know that Pb is lead, and you know O is oxygen. So you would say oxide. But again, Pb is one of the exceptions. It does need a Roman numeral. So if I look this up, there's one lead, there's one oxygen. So as long as I know the charge of oxygen, I've got lead. So oxygen is always 2 minus. So that means this lead has to be 2 plus. If you look up lead on the periodic table, it is in group 14, meaning it should technically be 4 plus, but in this compound, as you see, it's not. So it is one of the exceptions to the whole how many electrons it can lose. So that's why it needs a Roman numeral. So you would have to say lead 2 oxide. So that is how, just an addition to how we name ionic compounds. You've got to keep in mind that you've got to have a Roman numeral for those transition metals, and then also keep in mind that lead and tin will need them. So we're going to go ahead and practice some more of these, and this is the end of this video. Thanks.